gone into the website, there's a practice one you can print off and do. The key is there to see how you're doing. If you got 10 out of 10, you ought to be able to walk down and go take quiz number 1 without any problems. If you had some problems, get together with somebody, including those in the math lab or others in the class, and make sure you know how to do those kinds of problems. The first one is just whole numbers, and we're testing you on, do you know the arithmetic? Do you know the order of operations? And on this one, on these quizzes, we are not looking at, do you understand what's behind it? We're just saying, can you compute? Okay. Number 2, which will be due a week from Friday, will include the integers, which are the negatives, whole numbers and their opposites. The third one, which will be due the following Friday, is decimals. The fourth one includes fractions, and then the fifth one goes back and does all 4 groups. You are able to go and take them all in one sitting, and if you want. I don't recommend that, but those of you who feel like you're prepared and you've gone in and done the practice ones all the way through, you might do it in a couple of sittings. You do not have to wait till the week that they're due. You can go take all of them right now if you want. But number 1 has to be completed by this Friday successfully. Okay? You get 2 tries, and we've told them not to let you go in the same day to redo them. In other words, we don't want you running in Friday, an hour before they close, taking it, failing it, turning right back around, because you need time in between to go see what you did wrong and fix it up. So make sure that you get that taken care of.
Are those done in the testing center?
They're in the online testing center. You will need to log into Brain Honey. You can see the tests right there now. You just can't get to them because they are password protected. But the proctor will put the password in for you.
So do we just go to the testing center and
Say, I'm here to take arithmetic proficiency quiz number 1. And you get done with that one. If you're prepared for 2 and you want to do 2 at the same time, just go back through and do number 2.
And no calculators?
No calculators. You may be allowed, or you will be allowed to use scratch paper, and I recommend it. Okay. Of course, they will not allow you to bring the scratch paper out of the testing center when you're done, but you should be allowed to use scratch paper. Okay. They are not super difficult, but if you have had a good background in mathematics, you should do okay on them. But if you need some extra help, why, you can get that.
Where are the practice quizzes?
There's a folder called Arithmetic Proficiency Quizzes, and right in there you'll see it. Okay. Questions about those?
Is there a time limit?
No, they are not timed. Okay.
On the practice quizzes, it says we can only take it twice. Is that true?
That's correct.
Okay.
If you're not successful on your first 2 tries, then there's kind of a backup plan. The backup plan costs money.
Okay.
Okay? And I will say, if you are one of those who just doesn't go in and take it by the deadline on Friday, that's going to cost you money too. We're going to make you go through the same process of the people that would have done it. Just, it's kind of a responsibility thing. Yeah.
So it closes at 9 on Friday?
I believe so. Yep. And remember, you can only take 1 per day. So if you think you might miss, you need to get in at least by tomorrow. So that you have a.
Is it already open in the testing center?
Yep.
So we can just go in there?
Yep. And all the other 4 are open as well as the one that's due this Friday. You could do them anytime you want. We've got some people that have passed several already have been in and are done with several. Okay. Quiz questions? Questions from the quiz anybody wants to ask? On divisibility. Yeah.
The one with the W.
Okay.
Somehow I
Somebody
didn't.
have that one up so we could get the number.
I think I still have the number, and maybe I wrote it down wrong. Maybe that was the problem.
Go ahead.
I
Yeah.
have 32497 361 9W.
9
9 and then W.
and then W. Okay. So we want to know what W should be so that this number, 3,249,736,190 something, is divisible by 3. Did she get, somebody check that so that
That's right.
That's right. There's actually a couple of approaches we can do. Let's do, well, who thinks they know how to do this and could like to, you want to come up and, no sense in me doing it if one of you can do it, so.
What I did for this is first I crossed out all the 3s because those are divisible by 3, so I know those will work. Then I crossed out the 9s because those are divisible by 3 right off the bat. And then crossed out the 6 because that's divisible by 3. Then I added the 2 and the 1 together. That made 3, so I crossed them out. And left I had 7 and 4, which is 11. So I just counted up with what numbers were available. What plus 11 will make a number divisible by 3? So 1, that'll make that 12, divisible by 3. Then 4 makes it 15, which is divisible by 3. And then 7 makes it 18, which is divisible by 3. And those are the only numbers that I came up with.
That's one way to do it. Does anybody else have a different method? I'll come show that.
It's kind of the same kind of, I guess. Instead of crossing them off, because I get really confused with that, I just like added them all together. So I just found the total of all of them, so I just went 5, and then 9, and 18, and then 25, and 28, and then, yeah, there, 28, and then 34, 35, and then 44. So I just found the totals 44. And then I just went through the same process that she did. I just found numbers like in the 40s and 50s that 3 would go into. So obviously I found that 1 would be 45, and 45 is divisible by 3. And then
And how do we know 45 is divisible by 3?
Add 5.
Because 4 plus 5 is 9, which is divisible by 3, okay?
and then 48. Right, because that's pretty 12. And then 51.
And in order to get 45, 48, and 51, you had to,
We had to add the 1 and then the 4 and then the 7.
okay. There's a couple of different ways of looking at it. Any more questions from the quiz? Okay, thank you. Now what I'd like to do is, I'd like to review over the methods for finding the GCF and the LCM, the different methods that we have. Make sure you've got down all of these methods. So what methods do we have? Yep.
The unifying factorization of Venn diagram.
So Venn diagram. Yeah, there's no particular order on these, so we'll go ahead. Venn diagram. There were actually 2 different ways that we did Venn diagrams. What did we put in the Venn diagrams? We We had a couple of different approaches.
There's the factors.
Put in all the factors, right? So in a Venn diagram, we had the two numbers and they were overlapping, and we put all the factors of all the numbers, and if they happen to be a factor of more than one, we would put it in the middle, right? If they were a factor of both numbers. Okay? And then we would what? How would we find the GCF? Look at which number is in that intersecting, that center section there. We'd have maybe have several numbers in there, and we want the one that is the biggest. Okay? Then what else did we do with the Venn diagrams?
Prime factors.
Put in the prime factors. Okay, now we don't look in here and just take the biggest. What do? We put all the prime factors of the two numbers here, and if they have them in common, we put them here. And then to find the GCF, we what? We multiply all the prime numbers that are in there. You remembering this from the homework? So two different ways. LCM was the same thing, right? Venn diagram, we put in all the, not factors, the multiples. Can we put in all of the multiples? No, just get started on it, right? And put in the multiples. Then what do? We're looking for all the multiples that are in here, and we're looking for the smallest one because it's the least common multiple. Okay? By the way, we might mention that 0 is a multiple of every number, right? I could take 0 times 5 and get 0. I could take 0 times 12 and get 0. So 0 is a multiple of every number, right? So technically, the least common multiple of every number is 0. But that doesn't help us much. So when we talk about least common multiple, we mean other than 0, okay? So we put in all the multiples, find the smallest, or we put in the prime factors. It's actually, we can use the very same picture we used over here. Here, to find a GCF, we multiply these. What do we do with the prime factors for LCM? We multiply all of them. So we start here and we say that one times that one times that one. We use them all there, that one and that one and that one, and multiply everything in the entire diagram. Okay? Everybody with me on that? Do you remember doing that? Okay, so there's our Venn diagram. What other methods do we have besides those two Venn diagram methods? A set. That's the one we began with in the homework previous. The set method. List, underline, common, circle, biggest, right? I recommend we start with that one just because if you're going to teach this to students, it makes so much sense. If they know what factors are, you list them all, you underline them, that's the common ones, the circle the biggest, well that's the biggest common factor or the greatest common factor. It just makes sense. So we got the set method over here. Again, we list, we underline, common, and circle the what? Smallest. The least common one. Okay? What other methods have we got? The Euclidean algorithm. And you can talk about this in a couple of different ways. One is you can take the two numbers and build stacks. By the way, if you get two numbers that are like 3,465 and some, you don't want to get your Unifix cubes out and be breaking them off. So what was that method? Put the two numbers together. What? Break off the top of the tallest. Throw away the bottom of that one. Put them down together again. Break off the top of the tallest. Throw away the bottom. You keep doing that until what? Until they're both even. And when that happens, that's your GCF. The very closely related method that kind of speeds it up, especially for big numbers, is the divide what? Divide the little one into the big one. Then what? Ask the question, is the remainder 0? Okay? If the remainder is 0, then you stop, right? If not, what do? You divide the remainder into the smaller of the two, which is the divisor, right? You say, do I have a remainder of 0? As soon as you say I have a remainder of 0, how do you find the GCD or the GCF?
The last divisor.
It's the last divisor when you get the remainder of 0. Or, if it's in the problem before, it's the last remainder. If you go to the problem before that. Okay? And if you thought about the breaking off of the cubes and the dividing, they're really the same, except dividing makes it go quicker. Makes it go quicker. So, that's the Euclidean algorithm, and the Euclidean algorithm works only for GCF. It doesn't work for LCM. But if I find the GCF by the Euclidean algorithm method, there's another method that we can use. And we're going to, it's related to this, and we have to know the GCF to do this. And that has to do with this. If I take two numbers, A and B, if I multiply A and B, I will always get the very same product as when I take the GCF of A and B and multiply by the LCM of A and B. So if I know the two numbers and I know their GCF, I can find this quite easily, right? How?
If you multiply the two numbers together and then just divide it by the number that you
Yeah,
have for that.
this here is related. We would go A times B over the GCF of A and B, right, is equal to this. Because if I divide both sides by GCF of A and B, I get. So I can find the LCM of A and B with a little algebra when I get done. Right? Does that make sense? This is not the Euclidean algorithm, but I can take the results of the Euclidean algorithm, which gives me the GCF, and I can take my two numbers and that GCF and come up with it. Does that make sense? Okay.
Do you pick just any number? Do you pick just any number?
You can use any two numbers, A and B. This works for it. So if you're looking for the LCM of any two numbers, if you know their GCF and their product, you can get the LCM from it. Okay? Are there other methods for finding the GCF or the LCM? Yes. What are they?
Calculator.
Calculator. I like to call it technology.
Technology.
If you have a graphing calculator, technology works really nice. And you can do it over here as well. Technology. Let's demonstrate on a graphing calculator. Maybe. There we go. I have here a model of a TI-84. So if you have an 83 or an 84, 83 plus.
What about an 89?
89, it does it, but it's not the same key presses. But it has it. And I can help you find that if you need to. So, what you do is you hit Math, and then you come over to Number, and then you go to number 9. Okay, it says GCD, that's greatest common divisor, not denominator, which is the same thing as GCF. And let's just do a couple we know that we did it in our thing, 12 and 20. What should we get when we put enter? What's the greatest common factor of 12 and 20? 4. Push enter, and there it is, 4. Right? If I want LCM, I do Math, Number, and 8. And again, I'll do 12 and 20. And we get 60 is the smallest number that both 12 and 20 will go into. What if you don't have a graphing calculator? The internet works nice. Hit Explorer here. And I'm going to type in wolframalpha.com. Write that down. That could become your friend. wolframalpha.com. Wolfram Alpha is way cool. It's way cool. Way smart. Let's just try this. GCD of 12, comma, gotta have another number, 20, and hit enter. Come on. It says the GCD of 12 and 20 is 4. Oh, look what else it told us. That the prime factorization of 12 is 2 to the second times 3, and the prime factorization of 20 is 2 squared times 5. By the way, Wolfram Alpha is the brains behind, anybody know, heard of Siri?
No.
Who's heard of Siri? Siri. I just go, what is the derivative of 3x squared? Wolfram Alpha, it's reaching out to Wolfram Alpha right now. It says, look.
Check that. Here's what I found.
Okay, 6x. Got it right there, and it's got a graph of it. I could do the same thing here. You can have it do math for you. Let's see if it'll do LCMs, GCDs. What is the GCD of 12 and 20?
Let me check that. I found this.
Came up, it has some Newtonian gravitational constant, and let's try an LCM. Maybe, what did I say, GCD or GCF?
What if you said the word? Like, what if you said it like...
Oh, let's try that.
factor?
What is the greatest common factor of 12 and 20? Let's try that.
Would you like me to search the web for what is the greatest common factor of 12 and 20, Miss Tretta?
I started talking before I let it quit, so that's probably the problem. Anyway, we're not gonna play with Siri anymore. But Wolfram Alpha is the brains behind Siri. You need to get to know Wolfram Alpha, even if you don't have an iOS device. You can still use this. And let me just show you what Wolfram Alpha will do. Not only does it know how to do math, it knows it's a huge database out there. So I could put something like population of Madison County, Idaho, divided by the area of Madison. Oops, I can spell right. Madison County, Idaho, and I hit enter. And it says there are 79.32 people per square mile. And not only that, here is the people per square mile for the last, what, 40 years. See what's been happening in Rexford? Can anybody guess when the announcement to go from Ricks to BYU happened?
2000?
Anyway, Wolfram Alpha is your friend. You can put in anything. You can put genealogy in Wolfram. Yeah. By the way, to get all of the use out of it, takes a subscription, which is really cheap. I got my iPhone. I've got an app for Wolfram Alpha, and I think it was $1.99 when I bought it. I don't know what it is now. And once you get the thing, it gives you even more than just this is a free version. You can see it's, oh, by the way, if you don't like that, you can go people per acre, people per square kilometer, or people per square meter. Okay? So, anyway. Technology, you have no excuse. If you need to know something, technology will help you, right? Okay? If you have a spreadsheet, you can just call up your spreadsheet, and in the cell you have to put equals to start your formula, right? Equals, and then put LCM, comma, or LCM parent 12, comma 20, and hit enter. And Excel can do LCMs and GCDs as well. So let's not go any further with those. All right. There's one more besides these 1, 2, 3, 4. There's still another method. Did you catch it?
Was it the one where you divide the multiple of the two numbers by the greatest common factor to get the least common multiple?
That's this one
Oh, yeah,
here.
that's what we just did.
That's this one here. Okay? That's to find an LCM if you know the GCD and the two numbers. The other one's very closely related to this one here. I'm going to call it the prime power factorization method. Okay? How does it work? Let's just give you some examples. What if I tell you that the number is 2 squared times 3 times 5 squared times 7? That's one of our numbers. And our other number is 2 times 3 squared times 5 times 11. I don't know what either of these two numbers are. Do you believe me? I don't. But I'm going to tell you what their GCD is. And then I'm going to turn around and tell you what their LCM is. Who can do it? Who knows how to do it? Yes?
You take the prime power of each one.
GCF.
You make your Venn diagram.
Yeah. Let's do the Venn diagram to see where this comes from. So I've got a 2 here and a 2 there. That makes 2 2s in this one. This is my first number. And 1 2 in that one. Then what?
You have your 1.
1 3 here and another 3 there. Now there's 2 factors of 3 in that one. Then I've got a 5 here and a 5 out here, but no 5s out here. Then what? A 7 here and an 11 here. So now we're going to do what we just did here, and we're going to see if we can come up with it. What's this going to be? 2 times 3 times 5. Right? And the LCM will be what? Because you told me on this one, we just took what was in there and multiplied them. What do we do for this one? Multiply all of them. So I'm going to take 2 squared, that's that one times that one, times 3 squared, times 5 squared, times 7 times 11. I don't know what either of these two numbers are, but here's the GCF and there's the LCM. Question, comment?
I can't see it, but the 2 and the 3, the numbers that are in the middle of that, 5 or 3?
This number?
In the middle of the Venn diagram.
Here? This is a 5 and a 2 and a 3. Yes.
Is that kind of, isn't that already over there?
It is.
Okay.
This
I'm
is
just making
over
sure
there.
it's the same thing.
But what I'm trying to get you to do is, without building this, can you get it from just this?
Okay.
Yes.
I know how to find the LCM from just that.
How?
You're supposed to take the bigger number. Does that make sense? With the
The
exponent?
bigger,
The bigger number with the exponent. So the bigger exponent?
the larger exponent.
Yeah.
She's saying, I've got 2 to the second, I've got 2 to the what?
First.
On LCM, we will use the largest. Here I've got 3 to the first, 3 to the second. I'm going to use the largest, second. 5 to the second, 5 to the first, I'll use the largest. I've got 7 to the first here. What have I got 7 to over here? To the 0. It's really there. 7 to the 0. What's 7 to the 0? 1. I can multiply any number by 1 and it doesn't change it. It's really there, we just don't see it. I'm going to use the largest. That's the 1, not the 0. The 11, there's really an 11 to the 0 on this one, right? Which is the largest? 11 to the 1. Yes, that's what you do for LCM. What do you do for GCD? Take the smallest. Let's look. 2 to the second, 2 to the first. I'm going to use 2 to the first. 3 to the first, 3 to the second, I'm going to use 3 to the first. 5 to the second, 5 to the first, I'm going to use 5 to the first. 7 to the first, 7 to the 0, I'm going to use 7 to the 0. 11 to the 0, 11 to the first, I'm going to use 11 to the 0. So, for the greatest common factor, use the lowest power. For the least common multiple, use the greatest of the powers. It's kind of like the last shall be first and the first shall be last. The greatest uses the least and the least uses the greatest. Does that make sense? Now, did everyone see why I said it's very closely related to this one? But I don't need a Venn diagram to do it. I can just take the... Now your job tonight, one of your jobs, is to sit down and look at this and say, how are all of these related to each other? We've seen how the prime power factorization method is really closely related to the prime factors in the Venn diagram. But how are those related to all the factors? How are they related to sets? How does this tie into the Euclidean algorithm? And so forth. Okay? If you can put that all together, you have got this. Okay, what we're going to do next is, you might be asking yourself, why do I even need to know LCM and GCD? What good is it? How are my students going to use it? Does anybody have any ideas of what this problem, or what these two ideas from number theory are about? Anybody? What good are LCM and GCD? Other than to say, well, I can tell you how many factors there are in a number, you know, without knowing what the numbers are or whatever. Yeah. Okay.
Like to figure out, okay, what is the biggest number going to get in these songs?
We're going to look at some real-world examples. They're not by any means the only ones. And to begin this, I'd like you to watch a short clip of this video. If you've ever seen Father of the Bride, you may recognize this.
Ina said as long as I was escaping, would I mind escaping to the market and picking up something for dinner? Sure, that was all I needed. A busy supermarket. I needed to drive, mellow out, get my mind off the wedding. But mellowing out was not in the cards.
Excuse me, sir. What are you doing?
I'll tell you what. I want to buy 8 hot dogs and 8 hot dog buns to go with them. But no one sells 8 hot dog buns. They only sell 12 hot dog buns. So I end up paying for 4 buns I don't need. So I am removing the superfluous buns.
I'm sorry, sir, but you're going to have to pay for all 12 buns. They're not marked individually.
Yeah. You want to know why? Because some big shot over at the Wiener Company got together with some big shot over at the Bun Company and decided to rip off the American public. Because they think the American public is a bunch of trusting nitwits who'll pay for things they don't need. Well, they're not ripping off this nitwit anymore because I'm not paying for one more thing I don't need. George Banks is saying no.
Who's George Banks?
Hey!
Okay. As you work on this first problem, that could be a good introduction to it. You have 13 minutes to work with partners or whatever, after which time you'll take the rest of this home and do it for homework. Okay?